Welcome to the assignment for the RM9 lesson, Introduction to Dimensional Analysis. All conversions in science are done by a method called dimensional analysis. The given is multiplied by a series of brackets, each bracket containing a fraction. The numerator in the fraction always equals the denominator, making each fraction equal to 1. So according to algebra, anything multiplied by 1 is equal to itself. So multiplication of our given by these brackets does not change the amount we have. It just changes the units in which we are expressing the amount of given present. So here is an overview of how dimensional analysis works. A little complicated off the top here, but we're going to go through simpler examples, and by the end of this unit, you will be a complete master, I guarantee, of dimensional analysis. We always write down our given first, 82.8 kilometers an hour, and we want to know what that is in meters per second. So in the end, I don't want kilometers and I don't want hours. If I take a look, kilometers right now is in the numerator. And if I want to get rid of something in the numerator, I have to put kilometers in the denominator so it's able to factor out. And I do that by putting in large brackets. And I will put kilometers on the bottom so they can factor out. And I'm going to put meters on the top because that is what I want kilometers to be turned into. Now in my brackets, I want to make the top equal to the bottom. So 1 kilometer equals 1,000 meters. Now kilometers on the top can factor out with kilometers on the bottom. And if I were to punch this into my calculator, 82.8 multiplied by 1,000 divided by 1, that would give me an answer that is in units of meters per hour. Now that is not what I want. I'm good with meters. That's what I want in the end is meters, but I want the time to be in seconds. So I have to deal now with the hours. Hours are located in the denominator. To get rid of something in the denominator, I have to put it in the numerator. So I will put in another set of brackets and I will put hours on the top so that hours and hours can factor out. Now I don't want to jump directly to seconds because there's a step halfway in between, and those are minutes. So my bracket is going to switch hours to minutes. And in 1 hour, I know there are 60 minutes. So hours and hours can factor out. And if I punch this through my calculator now, 82.8 multiplied by 1,000 divided by 1 multiplied by 1 divided by 60, that would give me my speed in terms of meters per minute. Again, like we said, that is not what I want. I don't want minutes, I want to have seconds. So I will require another bracket. Minutes is currently located on the bottom, so I'm going to want to put minutes on the top, and then I will put seconds on the bottom. And that will allow me to switch the time from minutes to seconds. Minutes and seconds, I have to put numbers in, so top equals bottom. And in 1 minute, there's 60 seconds. Minutes on the top and minutes on the bottom will factor out. So now when I run this through my calculator, the only units left will be meters on the top and seconds on the bottom. And that's what I want. I want my speed in meters per second. So 82.8 multiplied by 1,000 divided by 1 multiplied by 1 divided by 60 multiplied by 1 divided by 60 equals 23.0 meters per second. Now 82.8 kilometers an hour is the same as traveling 23.0 meters per second. If you are driving down the road covering 82.8 kilometers in an hour, you are also covering 23.0 meters every second. They are equivalent, just expressed with different units. We are going to start with simple conversions, but all steps must be shown in order to learn the process. At first, this will seem redundant and a long way to accomplish our end goal, but if the steps are cut, it will affect your ability to use dimensional analysis with more complex questions that are coming later in the unit. You're going to be working with metric prefixes, and you have done metric prefix conversions for years now, but you did not do them using dimensional analysis. And the whole entire point of this is for you to take something you know, which are metric prefixes, and use that to learn how to use dimensional analysis, because dimensional analysis is going to be used in things a lot more complicated than your metric prefix conversions. So these are the rules of dimensional analysis, and it's going to seem pretty lengthy when you first look at it, but as time goes on, these rules are going to become second nature to you. You're going to practice it so often that you won't even have to think about what order do I do this in, because, like I said, it's going to become second nature. So first, write down the given, then you draw a large set of brackets. Put the unit you currently have in the bracket so it will factor out with that current unit. Then put the unit you want on the other side of that fraction. Put numbers in front of the units in the bracket so the numerator equals the denominator. And that is important. First, put your units in the bracket and then put numbers into the bracket that make top equal to bottom. A lot of times, this is where students run into trouble because they try to put numbers in before they have all their units in the bracket. Number 3, factor out units that appear in both the numerator and the denominator. Then you run it through your calculator. You multiply the given by the numbers that are in the numerator, and then you divide by the numbers that are in the denominator. And then write the final answer with proper units. Example 1. How many meters in 4,329 millimeters? I start all these questions the same way. I write down the given. So 4,329 millimeters is the first thing I will write down on my paper. Second step, I always draw a large set of brackets. Now I want to put the unit that I currently have in the brackets so it will factor out with that current unit. I have millimeters right now. If I want to get rid of millimeters, I'm going to have to put it in the denominator so that they will factor out. On the other side of that fraction, I will put the unit that I want to find, which is meters. So I'm going to put meters on the top. And then I have to put numbers inside the bracket so that the top equals the bottom. And that is why I have the metric prefix table. 1 milli equals 10 to the negative 3. I have milli on the bottom, so 1 milli equals, and on the opposite side of that fraction, I will put 10 to the negative 3. Because 1 millimeter equals 10 to the negative 3 meters. Top equals bottom. That means when I run this through my calculator, I will not be changing the length. I'm just changing the units that I'm expressing that length in. Right now it is in millimeters. After I carry this calculation out, I will have the exact same length, except it's now in meters. So factor out units that appear in both the numerator and the denominator. So I got millimeters in my given, and that will factor out with the millimeters in the denominator. Now I'm going to run it through my calculator by putting my given in the calculator, multiplying by the numerator, and then dividing by the denominator. So 4, 3, 2, 9 multiplied by 10 to the negative 3, so I use the caret button, and then negative 3 divided by 1. And that equals 4.329. So now I will write my final answer with proper units. 4,329 millimeters equals 4.329 meters. Example 2. How many meters in 0.674 hectometers? I start by writing down my given, so 0.674 hectometers, and then I draw a large set of brackets. I currently have hectometers. If I want to get rid of hectometers, I will have to put it in the denominator so that hectometers and hectometers will be able to factor out. On the opposite side of the fraction, I will want to place meters. And then I need to find numbers to put in front of meters and hectometers so that the top part of the fraction equals the bottom part of the fraction. And my metric prefix table says that 1 hecto equals 10 to the 2. So 1 hecto equals 10 to the 2. 1 hectometer equals 10 to the 2 meters. I factor my units out, hectometers and hectometers will factor out. I then run it through my calculator. So 0.674 multiplied by 10 to the 2 divided by 1 equals, and I will write my final answer with proper units, 67.4 meters. Example 3, how many nanoliters in 0.000000456 liters? Again, I start by writing down my given, so 0.000000456 liters. I draw a large set of brackets. I currently have liters, so to get rid of liters, I will place it in the denominator so that liters and liters can factor out, and I will put nanoliters in the top because that is what I am looking for. Now I need to make top equal to bottom, so I will reference the metric prefix chart, and it says that a nano equals 10 to the negative 9. So 1 nano on the top is equal to 10 to the negative 9 on the bottom. 1 nanoliter equals 10 to the negative 9 liters. I'll factor my units out, so liters and liters will factor out. I will run it through my calculator. So 0.000000456 multiplied by 1 divided by 10 to the negative 9. And then I will write my answer with proper units. And that gives me 456 nanoliters. Example 4, how many megawatts in 340,000 watts? Again, I start by writing down my given, 340,000 watts. And again, the next step is to draw a large set of brackets. I currently have watts, so to get rid of watts, I put it in the denominator. I want to find megawatts, so I put that on the opposite side of the fraction. I want to make sure the top equals bottom, so I reference my metric prefix table, and I see that a mega is equal to 10 to the 6. So 1 mega equals 10 to the 6. So in my brackets, I write 1 mega on the top equals 10 to the 6 on the bottom. So there is 1 megawatt in 10 to the 6 watts. Top equals bottom. I then factor out my units. I have watts on the top and the bottom that will factor out. And when I run it through my calculator, this wattage will now be expressed in megawatts. So 340,000 multiplied by 1 divided by 10 to the 6. And I'll write my answer with proper units, 0.34 megawatts. Sometimes it is not possible to get to the final answer with just one bracket. In that case, 2 or more brackets may be needed. Each bracket will get you closer to your final desired unit. Example 5. How many decameters in 4,329 millimeters? Again, I start by writing down my given. Then I put in a large set of brackets. Inside that bracket, I'm going to want to put the unit I currently have, in this case on the bottom, so that millimeters and millimeters will be able to factor out. And I will want to switch it to decameters. The problem is decameters and millimeters are on 2 separate lines. So in this case, I'm going to use 2 separate brackets. My first bracket is going to take millimeters and convert it to the base unit of meters. The second bracket will then take that base unit and convert it into decameters. So I'm going to want to go from millimeters, and I'm going to switch that to meters. As the metric prefix table says, a milli is equal to 10 to the negative 3. So 1 milli equals 10 to the negative 3. I'm going to put in a second set of brackets. Millimeters and millimeters have factored out, so I now have meters. So to get rid of meters, I will put it in the bottom of the second set of brackets. I want to switch that to decameters. When I look on the metric prefix table, it says that 1 deca equals 10 to the 1. So I'm going to put 1 deca on the top, and that is equal to 10 to the 1 on the bottom. Now, meters and meters will factor out. And when I run this through my calculator, I will have that length expressed in decameters. So 4,329 multiplied by 10 to the negative 3 divided by 1 multiplied by 1 divided by 10 to the 1 gives me my final answer with proper units, which is 0.4329 decameters. Example 6. How many kilometers in 0.674 hectometers? Again, start by writing down the given, and then a large set of brackets. I have hectometers. If I want to get rid of hectometers, I'm going to put it in the bottom. And the unit I want to find, I'll put in the top. The problem is hecto and kilo are on two different lines. So I don't want to jump directly to kilometers. Instead, I'm going to go to meters first. So I'll put meters on top. I need numbers to make top equal to bottom. And according to the metric prefix, 1 hecto equals 10 to the 2. So I'll put 1 with hecto, and then 10 to the 2 with meters. Now top equals bottom. Hectometer and hectometer will factor out. I want to get rid of meters now, so I put it on the bottom. I'm going to switch that to kilometers. And according to my metric prefix, 1k equals 10 to the 3. So 1 kilo equals 10 to the 3. Top equals bottom. Meters and meters will factor out. I run it through my calculator. 0.674 multiplied by 10 to the 2 divided by 1 multiplied by 1 divided by 10 to the 3. And that gives me my final answer, which is 0.0674 kilometers. Example 7. How many nanoliters in 0.000000394 microliters? I start by writing down my given and a large set of brackets again. I have microliters. I want to get rid of microliters, so I will put it on the bottom. I note that I have two metric prefixes. So my first bracket will take me out of my current metric prefix. The second bracket will take me to my new metric prefix. So I know I'm going to be using the first bracket to get to the base unit. My base unit is liters, so I will put liters on top. I want to make sure that top equals bottom, and in that metric prefix chart, it says that 1 micro equals 10 to the negative 6. Again, I want to put in numbers that make top equal to bottom. So 1 micro equals 10 to the negative 6. So therefore, there is 1 microliter in 10 to the negative 6 liters. I'll put in another set of brackets. And since microliter and microliter factored out, I now have just liters, but I don't want liters. I want nanoliters, so I will put liters on the bottom, so my current unit will factor out. And like I said, I'm going to switch that to nanoliters. I want top to equal bottom, and according to my metric prefix, 1 nanoliter equals 10 to the negative 9 liters. So I put those numbers in, so top equals bottom. I will then factor out my units, liters and liters factor out, and that will leave me with my desired unit of nanoliters. Run it through the calculator, 0.000000394 multiplied by 10 to the negative 6 divided by 1 multiplied by 1 divided by 10 to the negative 9. And then I write that answer with proper units, and that gives me 0.000394 nanoliters. Last example, similar to the others, but that's because repetition works. Write down our given, 340,000 megawatts. Large set of brackets. We currently have megawatts, so I'll put megawatts on the bottom. I want to get to gigawatts, but mega and giga are on two separate lines, so we will do two separate brackets. I'm going to use the first bracket to get to my base unit, which is watts. I want to put numbers in that will make top equal to bottom. 1 mega equals 10 to the 6. So 1 m equals 10 to the 6. Now top equals bottom. I'm going to put in another set of brackets because I know I'm not at my final unit. Megawatts and megawatts factored out. So I currently have watts. So to get rid of watts, I have to put it in the bottom so it's able to factor out. And I'm going to switch it to gigawatts. And giga is equal to 10 to the 9. So 1 big G equals 10 to the 9. Top equals bottom. Watts and watts factor out. I run it through my calculator. 340,000 multiplied by 10 to the 6 divided by 1 multiplied by 1 divided by 10 to the 9 gives me, with correct units, 340 gigawatts. Before we finish up, I would be remiss if we did not talk about significant figures. When doing a metric conversion, the number in the brackets do not count for determining significant figures. This is because the top and bottom are exact numbers. There are exactly 100 centimeters in a meter. There are exactly 1 million microliters in a liter. So that does not count for our significant figures. If we were converting from kilograms to pounds, this would not be an exact conversion. 1 kilogram equals 2.2 pounds states that 1 kilogram is approximately 2.2 pounds. The 2.2 will limit our answer to two significant figures. So if I weigh 176 pounds and I want to know what that is in kilograms, inside brackets, I would put 1 kilogram over 2.2 pounds, so the pounds would factor out. My given has three significant figures. The bracket says 1 kilogram is equal to 2.2 pounds, which only has two significant figures. So my answer is only allowed to have two significant figures. Remember, multiplication division rules would apply. So 80.90909 to two significant figures would be 81 kilograms. And that brings us to the end of the examples. You're good to begin the RM9 assignment.